In this video, it will be seen that armature reaction can be represented by equivalent reactance XAR. Equivalent circuit of generator is done. With the help of equivalent circuit, Phasor diagram is obtained. Voltage regulation is also covered in this video. For all practical purpose, simplified equivalent circuit may be used. Let us examine first what happens when external reactance is introduced between generator and load. Suppose a resistive load is connected to the generator. An external reactance is introduced between generator and the load. EMF induced in the external reactance opposes the induced EMF in the generator. Induced EMF in the external reactance leads the current by 90 degrees. Now let us draw a phasor diagram. Since it is a resistive load, current is in phase with terminal voltage. Induced EMF in the coil is drawn perpendicular to current. EMF induced in a generator is a phasor sum of terminal voltage and voltage drop in external inductor. Now let us examine what is the effect of armature reaction. Again we have taken a resistive load, that is current is in phase with voltage. Direction of flux produced by armature current can be found by applying right hand thumb rule. Due to armature flux, main flux is distorted. Resultant flux is a phasor sum of main flux and armature flux. It may be noted that maximum EMF is induced when resultant flux faces conductor and not the main flux. So let us rotate the poles so that resultant flux faces the conductors. Induced EMF lags the main flux by 90 degrees. Terminal voltage lags the resultant flux by 90 degrees. The phasor difference between these two is the voltage drop due to armature reaction. The voltage drop due to armature reaction is denoted by IXAR. Thus we see that phasor diagram with external reactance and armature reaction are similar. Effect of armature reaction can be denoted by equivalent reactance XAR. XAR is an imaginary reactance which takes into account effect of armature reaction. Now let us draw an equivalent circuit of a synchronous generator. Induced EMF E and XAR are drawn. Reactance XL due to leakage flux is drawn. Internal resistance R of stator winding is also drawn. Since XAR and XL are similar, these are combined together to form synchronous reactance XS. Synchronous reactance and resistance are combined together to form synchronous impedance. . Synchronous impedance is so called as it impedes the synchronous speed. Thus, the equivalent circuit of synchronous generator is drawn. Now, let us draw a phasor diagram. Resistance R is obtained by VI method. ZS is found by OCC and SCC characteristics. Let us cover the procedure very briefly. In OCC, generator is run without load and voltage versus field current is plotted. Since no current is flowing, there is no voltage drop. Hence, terminal voltage is equal to induced EMF. In SCC, generator is short circuited. Armature current versus field current is plotted. OCC and SCC are plotted on a same graph. Against rated voltage, field current is found. Against this field current obtained, armature current is found. Synchronous impedance ZS is a ratio of rated voltage and armature current. Synchronous reactance is under root of ZS square minus R square. Knowing internal resistance R and synchronous reactance XS, phasor diagram can be drawn. Let us start with the terminal voltage V. Let load current I lags voltage by 5 degree. IR drop is down in phase with current. Drop due to synchronous reactance is perpendicular to current. Induced EMF is a phasor sum of terminal voltage V, IR and IXS drop. By using the phasor diagram, voltage regulation can be calculated. It is defined as increase in terminal voltage when load is reduced from full load to no load. It is given by drop in voltage when load is connected divided by terminal voltage, or it is equal to IZS by V. As seen, if synchronous reactance is more, voltage regulation is poor. For all practical purposes, internal resistance is neglected and simplified equivalent circuit may be used. Reactance due to armature reaction XAR is much larger than leakage reactance XL. Voltage regulation may be improved by reducing excess, that is by increasing air gap between stator and rotor. However, more excitation is required to maintain flux or induced EMF, thus resulting in increased cost of generator.